In this video, we'll dive into C++ references. References are a fundamental concept in C++ that allows you to create aliases for variables. We will explore how to create and use references as aliases to variables. So, what exactly is a reference in C++? A reference is essentially an alias to an existing variable. Think of it as providing an alternative name for a variable that has already been defined. Once a reference is initialized, it cannot be changed to refer to another variable. It sticks with the original variable it was set up to point to. Here's an example. First, we create an integer variable named number and assign it the value 42. Next, we create a reference to number called ref. Now both number and ref refer to the same memory location. This means that if you change one, the other is also affected. Let's look at an example of how references can be used to modify variables. First, include the iostream library. Inside the main function, we declare an integer variable named original and initialize it with the value 10. Now we create a reference to original called ref. Then we print the values of original and ref to the console. Next, we modify the value of ref to 20. Finally, we print the values of original and ref again. Notice that modifying ref also changes the value of original. The output shows that initially both original and ref are 10. After modifying ref, both original and ref become 20. Now let's explore the key differences between references and pointers. References must be initialized when they are declared, whereas pointers can be declared without initialization. References cannot be null, meaning they must always refer to a valid object, while pointers can be null. Once a reference is initialized, it cannot be reassigned to refer to a different object, whereas pointers can be reassigned to point to different memory locations. To access the value pointed to by a pointer, you need to dereference it using the asterisk operator. References, on the other hand, don't require dereferencing, providing a cleaner syntax. References are generally considered safer than pointers because they cannot be null and cannot be reassigned, reducing the risk of common pointer-related errors. Let's see how it is represented in memory. On the left, we have number variable stored at memory location 0x1000, and on the right we have ref variable, which is pointing to the same memory location as number variable. In case of pointers, the PTR pointer variable is stored at a separate memory location 0x2000, which contains the memory address of the number variable. Now let's see how to pass reference as function parameters. Pass by reference allows functions to modify the original variable directly. It avoids copying large objects, which makes it more efficient. When a function receives a reference to a variable, it's working directly with the original data. Any changes made inside the function will affect the original variable. Let's see it with an example. Here we have function named modifyValue, which takes one argument, an integer reference named value. Inside the function, the value parameter is multiplied by 2, modifying the original variable passed to the function. In the main function, the integer variable number is initialized with the value 10. The modifyValue function is called with number as the argument. After the function call, number will be modified, so it becomes 20. Let's explore the benefits of const references. Const references prevent modification of the reference variable. It provides the efficiency of pass by reference, without the risk of accidentally modifying the original variable. They are commonly used for function parameters, and they are the best practice for passing large objects when you only need to read their values. Const references provide read-only access to the original data, ensuring that the function cannot change it. Let's see it with an example. The function named printValue takes a constant integer reference as input. This guarantees that the function cannot modify the original variable. Inside main function, we declare an integer variable number with value 42. Then a const reference ref is created, referencing the number variable. Since ref is a const reference, you cannot modify the value of number through ref. However, you can still read the value through the reference. Now let's discuss references as return values. A function can return a reference, allowing the caller to directly modify the original variable. However, it's crucial to ensure that the object being referred to outlives the reference. This is safe as long as you are not returning reference to a local variable. Let's see it with an example. The function getLargest takes two integer references, a and b, as input. It returns a reference to the larger of the two values. In the main function, two integer variables, x and y, are initialized with the values 10 and 20, respectively. A reference ref is created, which gets the return value of getLargest function. The ref variable contains the value of y variable, since it is the largest. The value of ref is updated to 100, which also updates the value of y variable. Finally, the updated values of x and y are printed. Let's examine some common pitfalls to avoid when working with references. One dangerous practice is returning references to local variables, as the local variable will be destroyed when the function exits, leaving a dangling reference. Dangling references occur when the object being referred to has been destroyed, leading to undefined behavior. Reassigning references is not possible in C++, as a reference is bound to its initial object for lifetime. Also, null references are not possible in C++. Finally, be cautious of references to temporary objects, as the temporary object may be destroyed before the reference is used. Here is an example for dangerous practices. First, returning reference to a local variable is demonstrated, where the local variable will be destroyed when the function exits. The next example shows reference to temporary object, which results in an error. Finally, it attempts to reassign a reference, which actually modifies the value of the original variable instead. Here are some best practices to follow when working with C++ references. Use const references for read-only access to large objects to prevent accidental modification. Use references instead of pointers when possible, as they are safer and provide cleaner syntax. Never return references to local variables to avoid dangling references. Use references in function parameters to avoid copying large objects, improving efficiency. Be careful with references to temporary objects, as they can lead to undefined behavior. In summary, references provide an alias to existing variables, offering a way to indirectly manipulate data. References must be initialized when declared, ensuring they always refer to a valid object. References cannot be reassigned, providing stability and preventing accidental changes in reference. References are safer and more convenient than pointers, reducing the risk of common pointer-related errors. Finally, references are commonly used for function parameters and return values, enabling efficient and expressive code. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.